can we just have a quick recap of what we said yesterday? The discriminant, there are three conditions, the discriminant that can tell us something. When the discriminant is greater than 0, what does that mean? There are two roots. And the discriminant equals 0, one root. Discriminant is less than 0, no roots. No real roots. Okay. So we saw some stuff yesterday about the discriminant, those conditions there. But we're just considering that in terms of a quadratic function and its parabola and where it cuts the x-axis. We can use this same information to think about where a straight line, a different straight line, not the x-axis, where a different straight line cuts a parabola. And so let's do an example of that now. So let's consider these two functions. One is x squared minus x, and one is 2x minus 2. If we were to draw these, first of all, x squared minus x, how do we work out where x squared minus x cuts the x-axis? How do you work it out? Factorise it. X by x minus 1. Therefore, where does it cut the where does it cut the x-axis?
1 minus 1.
1.
One place it cuts is at 1. That's right. Where's the other place?
0.
0. So from this section of it here, cuts it at 1, and from this section over here shows that it cuts at 0. Okay, so cuts there and cuts there. It's going to come down, go through like that, something like that. Okay. What about this one here? What does that one look like? Y equals 2x minus 2. What can you tell us straight away? Where does it cut the y-axis? Not at 2, at minus 2. Down here, minus 2. What's its gradient?
2.
2. So, where's it going to cut the x-axis? We've got a gradient of 2.
4.
It's going to go up 2 and across 1. Up 2 takes us to the x-axis, across 1. It's going to cut here, isn't it? Something like that. Now, having drawn that, it's interesting to know, is my shape accurate there? And again, this is not what we're considering now, it's kind of how accurately I've drawn this. But it looks like it may well cut the parabola twice, or maybe just once, depending on how well I've drawn that. And so even drawing that kind of tells us, well, how do I know? How do I know if it cuts it once or twice? And so what we can use is the discriminant by solving these two simultaneously. And let me take you through one of them. So I've got this one as equation number 1, this one as equation number 2, and I can sub 1 into 2 to solve where these two are true at the same time. Remember, that's what we're talking about when we're talking about where a straight line cuts a parabola. So where are those places, or where is the one place, depending on how many times, that those two equations are true simultaneously? That's the whole idea of simultaneous equations. Where are they both true at the same time? And so you solve them simultaneously. One of the methods is substitution. So I'm going to substitute number 1 into number 2. And I'll get x squared minus x equals 2x minus 2. And then from that, I can rearrange that into something that's a quadratic equation on one side equal to 0 on the other side. How will I do that? How will I move this information on the right-hand side onto the left and make it equal to 0? What do?
Minus.
Okay, so I'm going to take away 2x from both sides. X squared minus x, take away 2x is minus 3x equals negative 2. What do I do now?
Plus 2.
Add 2 to both sides. x squared minus 3x plus 2 equals 0. Now, I've got a quadratic equation on one side, equal to 0 on the other side. I'm trying to work out, well, where does this whole thing equal 0? Just to kind of step back again where we come from. We started with a different quadratic equation. That was a drawing of this parabola here. But I've solved that simultaneously, I'm in the process of solving that simultaneously with this linear equation, this straight line here, and I'm working out where do those two equations match up, where are they both simultaneously true. And by doing that, I actually come up with a new quadratic equation. From this point, I can consider the discriminant of this one and see, are we going to have two crossings? Are we going to have one crossing, which just means a touching, or no crossings? Okay, are we going to cross it twice, once, or no times? I can see already, knowing that both of those lines go through that point, it's going to be 1 or 2. It's not going to be 0 roots, because I know that for sure, because I know that does go through 0, 1, sorry, 1, 0. Both of those lines go through 1, 0. And so I know it's going to be at least 1, but it may be 2. So let's see, what's our discriminant? Discriminant equals b squared minus 4ac. What is b? It's negative 3. So negative 3 squared minus 4 times 1 times 2. 9 minus 8 equals 1. So I've got a discriminant that is greater than 0, therefore 2 roots. Okay? So I do have 2 roots. So I'm going to have to go through and work out, well, what is the other place that it works out, that it crosses. So I know it crosses at 1, 0. I've got that fairly easily just by looking at intercepts. But where is this other place down here? So I'm considering this place down here. What is that? So I'm going to have to go through and solve the rest. If it had turned out to be just 1 root, it would have been nice, because I could have known what it is straight away. But I'm going to have to go through and solve the rest now. So let me just take this space over here. So I've got to go back to my equation here now. So this one has got 2 solutions. I know one of them is x equals 1. What's the other one going to be? What are my alternatives for solving this? I've got 2 methods to solve it.
Elimination.
This one, I'm solving a quadratic equation. How do I work out what x is? Sorry?
Expand it.
Well, that's in expanded form. What's the opposite of expanded?
Factorize.
Factorize. I could factorize it, or I could use the...
Fudge.
Don't need a fudge method because there's no multiple x
Formula.
quadratic formula. Okay, so remember that's the two things that I've got. I've got a factorizing, or I've got the quadratic formula. And remember the fudge method is really just another version of factorizing. It's just factorizing when you've got more than 1x squared. Okay, so the fudge method kind of fits inside that. So I've only got the 2 alternatives, to factorize or to use the quadratic formula. What do you want to use?
Quadratic formula.
Quadratic formula. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a equals negative b is 3 plus or minus the square root of negative 3 squared minus 4 times 1 times 2. Even though, you know what, I didn't actually need to write that because I've already done it, haven't I? I've done it here already. So I could have just gone, at that point, 1. So I've already figured that out. Down here. I already figured the discriminant out, didn't I? Over 2 times 1 equals 4 over 2, or 2 over 2 equals 2 or 1. What does it mean?
The intercepts?
Yeah.
The x?
That's right. It's where these 2 lines cross. So remember what I've done. I've started with a quadratic equation, and a linear equation, and I wanted to know where do they cross, so I've solved them simultaneously, and I've put them into a form that's a new quadratic equation, and then use the quadratic formula to tell me what the solutions are to that. And so I can know that x equals 1 or 2 from what I had over here. So that is not where, it's got nothing to do with where these two cross the x-intercept, the x-axis now. What this is saying is where this one equals 0, which was where these two were solved simultaneously. Okay, so these two lines cross at 1 and 2. It also means that my drawing is a bit done. Which is why we need to solve like this, isn't it? We need to do this. Because I can draw and go, it looks like it's going to be about 0.7 or something. Actually, totally wrong. My drawing was no good. It actually crosses up here, somewhere, at x equals 2. So my parabola drawing was very ordinary. I'm not even finished yet. I've only worked out the x part. I've then got to work out the y part. Okay? And so to do that, I've put these two values into one of those two. I want to choose this one because it's much easier. Okay, I've got no extra stuff to go with, no squares. So I'm just going to go at x equals 1, y equals 2 times 1 minus 2. I'll just put 1 into that. And so y equals 0. And at x equals 2, y equals 2 times 2 minus 2 equals 2. So the 2 points are 1, 0 and 2, 2. Okay? They're my 2 points where those two equations coexist. Now, do you want me to try and draw it better?
Yeah,
I'll
maybe
try and
just
draw it. Alright, so I do know this one crosses the y-axis at -2 and the x-axis at 1. I know this one crosses the x-axis here and here, and I know that the two of them cross up here at 2, 2. And so I'm going to draw this one. That's my straight line. Y equals 2x minus 2. And I'm going to try and draw then a parabola. I'll draw it a different colour. Try and draw a parabola that matches these things. Right, kind of like that. I think actually what it would look like.
Yeah.